Okay, so we're at number 7. This is section 5.7. So today is all about, real life applications of all this exponential power log stuff we've been learning. Like, where does all this stuff land in the real world? So specifically, 5.7, this section, is all about economics. It's economic applications. And then 5.8, which we'll do half of today, that is chemistry and biology. So I'm not sure what your favorite is among all those, but we're going to hit them all. Mostly economics today, and then a little bit of biology and chemistry, and more biology and chemistry next Tuesday. All right. So the two formulas we're going to use, pretty much both these sections. It's the one that's on the board already. I'll write it again for you. It's A equals P 1 plus R over N to the NT. Remember that one? That's for financial investing. And then the other one is A equals PERT. When do we use that one? Continuously. Yeah, continuously. If it says that if it's compounded continuously. Yeah, so the PERT one is only for continuous compounding, which is everything in the next section. We'll use both these formulas in this section, and then in the next section, which we're going to do half of today, 5.8, I'll just say that in 5.8, it's all PERT. Why? Because biological living things, they grow continuously. They don't grow in jumps, So it's in 5.8, we're going to use nothing but the PERT formula. But in this money section, economics, 5.7, I'm sorry, the one we're in right now, 5.7, we're going to use both formulas depending on how the compounding goes. If the compounding is, remember how these work? If n is 2, what is that compounding?
Semi-annually.
Semi-annually, twice a year, huh? If what if they say compounded monthly? Monthly. And so remember, because n is the number of compoundings per year. So n equals number per year. So on this one they're saying compounded daily. 365. So n is 365 compoundings per year daily. All right. So let's write out the formula. So we're using the big formula, because it doesn't say compounded continuously. So I'm using the big formula. Let's plug in where's the 5,000 go? Let's start off with the numbers.
A.
Yeah, does everybody see the 5,000 is actually the A, because that's the amount you want to get later. Is that making sense? So in other words, when you use it, it's going to be the same thing when we use the PERT in the next section with chemistry and biology examples. The A is always the amount later, and the P is always the now. It's the principal now. So when we get to biology examples in 5.8 at the end of the hour today, into the hour and a half, it'll be like insects, how many insects started off and grew to be more insects.
Fruit flies.
Yeah, now it's how much money was first put in and grew to be more money later. Same thing though, right? P is always the now, the principal investment or the amount of living things now. The A is the amount later that it grows to become. Okay, so they're telling me that it grows to become 5,000, right? To get 5,000, so it becomes 5,000 later. So the A is the 5,000. The P, I don't know. That's what I'm trying to find. Find the principal. And what's the R? 0.08. What's the N? Oh, yeah, we already went over that, huh? 365. And the N and the T?
3.5 years. We'll convert it to 7 halves.
I'm just going to make it a decimal, I think. I'll just put it in 3.5 for the time right there. And there we go. So now I want to solve that for the P. So here, let me go to a fresh screen here because I'm running out of room. P1 plus, what was it? 0.08 over 365. to the power 365 times 3.5. Like that. Okay, so how do I solve for p there?
You can divide the whole thing over 2 by
That whole thing, yeah, just divide that whole thing. In fact, why don't it'd probably be helpful just to find that number in the power zone there. What is that? 365 times 3.5. Whoop. 1277.5. So I'm going to divide both sides by that. 1277.5. Boom, boom. So there we go. The P will equal. Yeah. Now let me give you a way. You can just do it direct if you want to. It might be nice when you type that into your calculator to just start with the inside. 1 plus 0.08. So on the calculator, you can. Let me just give you a quick way. I don't know if you know about some of the buttons that might be helpful. 1 plus 0.08 divided by 365. And then just hit enter, and you've got the inside, and then you can just go to the power of 1277.5 and hit enter, and then you guys with me so far? So here's a quick way. This way you won't have to mess with parentheses or anything. If you just type in the inside, just 1 plus 0.08 divided by 365, enter. I just keep hitting enter like whenever you hit enter, it calculates it right then. So that calculates the inside, and then just go to the power, and it'll assume you mean the last answer to the power, which is perfect. That's just what I want. The last answer to the 1277.5, enter. Now we have the whole denominator, right? So then the last thing is to go 5,000, the numerator, divided by, now do you know the button that calls forth the last answer?
Answer.
The answer button, exactly. Yeah, hit second and answer. It looks like it's above the negative button on the, if you have the graphing calculator, it's right above the negative, the very bottom. So most calculators, it's near the very bottom. The A and S button, hit second answer, and then enter. And that's really convenient. I don't know if you ever use the answer button on your calculator. Super convenient. That way you don't have to write anything down, or it just grabs the last answer whenever you need it. And let me get the answer here. So 1 plus 0.08 divided by 365. So I never have to use parentheses this way.
To the nearest whole dollar, because I'm not going to invest 3 cents. Not going to do it.
I'm getting 3,779 and 3 cents.
He does.
Is that it? Is that good?
I'm not going to invest 3 cents.
Y'all getting that? Questions on that one? All right. So there we go. So I'm going to move ahead if you're good. Let's just start off with just a real life situation. Let's say you take $5,000 at 10% annual rate compounded 1 time per year. So let's forget about the formulas. Let's don't use these formulas right now, because I just want to get you thinking. I mean, I know you could use those formulas; they'd work, they'd be great, and everything. But I just want to get you thinking about what compounding really does, because I'm going to derive another formula. I want to show you where it comes from. So, what would you could do that before you ever had these formulas? You would know how to handle that, huh? What would you do? $5,000. Basically, it's going to grow 10%, huh? How do you make $5,000 go up 10%? You would just take 5,000 times 0.10, huh? Good enough? Easy enough? You don't need some fancy formula. Just 10% of $5,000, which should just be $500, right? And so what would be the new amount? It would grow by $500. So it'd be $5,500. Exactly right. Now, so that you already know that. So now let's change the question a little bit. Now, here's what they're going to do. They're going to say, okay, 5,000 at 10% annual rate, so far the same, But now comes the different part. Compounded, instead of 1 time per year, they're going to say, like maybe 2 times per year. Now, I know we've already done this, and we got it. We just use the formula. Right. But I want to just do it by hand without the formula, so we can think about what's really happening. So when I drive this other formula, it'll make sense. So what's really, first off, do you know the language, the investment language, and what they even mean when they say 10% annual rate compounded 2 times? Like, what do they even mean? It's kind of a weird way they talk. It doesn't mean, it sounds like it does, but it doesn't mean 10% twice. It's actually 5% twice. It's kind of weird, huh? So I wanted to first off let you know about that. So when they say 10% annual rate, see, that's the key, meaning 10% for the whole year. So when they say something is annual, like if I said, hey, annually our garden produces, 10 pounds of strawberries. That means for the whole year, right? So when they say 10% is the annual rate, they mean for the whole year. So they say, and we're going to do it twice. So that's got to be 10% for the whole year, so it can't be 10% twice. It means it's 5% twice. So that's what they actually mean. So first off, that's what they even mean when they talk this way. So if it's 10% annual, but it's done twice, that must be 5% each time. Okay, great. Won't that just be the same, though? I mean, who cares, really?
No.
Actually, it's a little higher, isn't it? Yeah, do you know that already? It comes out a little better than just 5% twice is actually a little higher than doing 10% once. Why? Why is it? That's weird. Let's actually go through it. Do you want to say something,
No.
Renee?
No.
Let's go ahead and just do it, and we'll see. So I'm going to do 5% twice, right? So I'll just write it here. 5% twice. Okay, so let's start with the original $5,000, and let's just put 5% onto $5,000. So I just multiply by 0.05. You know how to do that, no problem. Now, I hope I'm not confusing. I know I would actually use the formula if I was solving a real life problem here. I'm just trying to give you the feel because I'm about to come up with a new formula. So that would be what, $250? Mm-hmm. Because it's half of 500, right? 10% was 500, so 5%. It's got to be half that. 250, okay. So 250, so yeah, right, so that's 5%, but then we're just going to do 5% again. Why is it not just another 250 and 250 is 500? It's exactly the same. Why? It's not that, huh? Why not? Do you know? Renee?
Of course I know.
Well, tell me. What is it?
Well, because you're going to add the 250 to the 5,000.
Exactly.
You're going to take the 5% and 52.
That's right. So probably a lot of you are seeing that, huh? Yeah, because if halfway through the year they pay you 5%, and then at the end of the year when they pay you the next 5%, it's not just 5% on the original 5, but now halfway through the year your account grew by 250, didn't it? So now you have 5,250, and they'll pay you 5% of that. Is that making sense? So it's going to be a little higher. So that's where it is. It's 0.05 times 5250, and so that's 262.5. Add those up. I think that's $512.50.
Okay.
So it's not dramatic. You get an extra $12.50. So why did that happen? Why is 10% done twice, 5%, 5%, actually a little better than just 10% once? Because the second time you get interest on the interest. Right? See what happened there? Halfway through the year, we got 5%, which was $250 interest. And then that interest, they gave us interest not only on the original 5, but on the interest they gave us halfway through the year. They gave us interest on the interest. That's a good deal. Mm-hmm. They call that compound interest. Yeah, compounding. They're compounding interest. They're paying interest on interest. Right? Get the idea? Interest on interest. So compound always means, one thing on top of another. Just boom and boom. They're just compounding them, right? They're putting them together. So I'm always reminded when I think of that of a little higher interest on interest. That's why they call this compound. That's why Einstein called it the seventh wonder of the world, compound interest, because you're paying interest on interest, just grows and grows. All right, so now what we want to do is in this section is now answer, what's the effective rate then? So if it's a little better than 10%, how much better? I mean, is it 11%? What, 10.5? I mean, how do you really know like what the actual effect is going to be? If it's, it's more than 10%, it's not really 10% because you're doing it twice and the second time is interest on interest. So what is it really? How could we figure that out? Well, so now that you got the idea, it is going to be, the answer is going to be something like 10.5 or 8 or something. Maybe we'll figure it out in a second. How do you do it? How could you come up with it? Well, think with me. If I told you, hey, I took $1, just $1, and I invested it in some whatever account, and it came out to be $1.07 at the end of a year, after 1 year. So if I said my one little dollar became $1.07 after 1 year, what did it grow by?
7%.
Yeah, you know right away, huh? You would, and you guys are all thinking 7%. You're totally right. And how would you formally get that? You're knocking off the original dollar because that's just what was originally there. That's not the growth, huh? Right on. And then you're taking the 0.07 and you're moving the decimal twice because that's how you turn it into a percentage. Exactly. So do you see if we just find out what happens to $1 after 1 year, then we can figure out what's the real effect of the account, huh? So that's exactly what I'll do. And I'll write, but I have it on the board for you already, and I'm going to write it out for you now. That's exactly what we're going to do for effective rate. So to find, whenever they give us effective rate, question, number one, I'm going to put in P equals $1, the principal $1, for time equals 1 year, because we want to know what happens after 1 year. They're always, whenever they say effective rate, they mean annual rate. A rate for 1 year. So put in $1 for 1 year. And then step 2, you know what you do with that answer, right? Answer, you subtract that original dollar because we just want the growth. And then we change to percent, meaning we move the decimal right 2 places. So that's the game plan, isn't it? That's what we do to figure out the real effect. See how that'll give us the real effect of any account? Show us what's really happening. If you can find out what happens to $1, you know what's happening to every dollar. You know the real effect of that account. So that's what we'll do if you're ready. So if you didn't get it quite, it's on the board there. So here we are, and what is question? So 12.25%. That's what they call the APR, the annual percentage rate. 12.25. That's the listed rate. So let me make that into a decimal. A quarter is what decimal? If you say I got a quarter, how much money? 25 cents. Huh? So 12.25. So that's the listed rate. But in reality, the effective rate is going to be slightly higher. Yeah, let me back up for just a second. I don't think I said that very clearly, what I wrote up there. Let me write that up here. How did I write it? If it's only compounded 1 time per year, then the effective rate is the same as the listed rate. Yeah, did you get that part of the deal? So if they're only compounding once a year, then it's going to be the same as the listed rate. It's going to be exactly the same, right? That's what we saw in this example back here. I'll go back to that, but or it's on the sideboard if you need it as well. So, right, when we did $5,000 just one time, well then, it's $500. It's just 10%. There's nothing magical. It doesn't go up at all. But if you do it 2 times, more than once a year, it actually has a higher effect. All right, so let's take a look. So they're telling us, where is it? There it is. They're telling us, all right, 12.25%. That's the APR. That's the listed annual percentage rate. But what's the real effect? What's really going to happen? Are they compounding more than once a year?
Yeah.
Yeah, quarterly, 4 times a year, huh? So that's going to be N equals 4. So it's going to be a little higher. It's going to go a little higher than 12.25. How much higher will it go? Which formula am I going to plug into? The big one or the PERT? The PERT is only used for if you compound continuously. So we're not continuously, we're just quarterly. So I'm going to use the big formula. P1 plus R over N to the NT, like that. All right, and to find the effect, to find what actually happens, remember what we do? We just put in P equals $1 for T equals 1 year. So to find the actual effect, we always just put in $1 for 1 year. $1 for 1 year. Right? Because if you can find out what happens to $1, you'll know the effect, huh? So let's put in $1. And the rate, the listed rate, I got to make it a decimal, right? 0.1225. Over N. N is 4. T is 1. There it is. Hit the buttons on your calculator. I'm getting 1.12824. Yeah, so now we got to convert it, huh? Good so far? That's, in other words, that's what happens to $1. That's the effect on $1. $1 becomes $1.12 and 824. So now we have to change that into a percentage effect. So cut off that 1, right? Because that's just the original dollar. We just want the growth. Is that making sense? And then move the decimal 2 places. So that'll be 12.824%. That's the actual effect. Effective rate. So really, even though it's listed at 12.25, the actual effect is 12.824. That's what it'll really do to your money. That's the real effect. Every dollar will grow by 12.824%. Rachel.
Get rid of the 1?
Oh, because that's just the original. So just think back to, like, if I told you, hey, I had $1, I invested it, it became $1.07.
Oh, right. Okay.
Right? So the dollar doesn't matter. That's just what I originally put. The growth is all we care about. It grew by 0.07, make that a percentage. Yeah, so all we care about is the growth, which is the effect. The original dollar we don't care about. Does that make sense? They call that APY, annual percentage yield. Yield is like effect. So, and by law, truth in lending laws say they have to list that. They have to give you that number when you take a loan.
So if you take a loan that's like, or if you get a car loan and they have 0% APR, is it?
Oh yeah, that's
I mean,
that's
like,
zero.
That has to be 0.
Oh, that's zero. Zero is zero,
You can't do
for sure.
anything else with it.
Yeah, that's always a great deal. Yeah. Yeah, 0% APR is fabulous, yeah.
Someone with my credit gets a loan with 12%.
We're going to do 13. Yeah, I want to skip. Whoops, I think I'm skipping. I'm getting confused. Yeah, there we are. So yeah, let me go back. So this was actually, it was 11, wasn't it? So this was problem 11, actually. Okay, let's go forward and do 13. 13 basically says, which is larger? It's going to give us 2 options. The first one's going to be 12% compounded quarterly. 12% compounded quarterly. And the other option would be 12.5% compounded annually. Okay, so which of those two is larger? 12% quarterly or 12.5% annually? So, they give you a couple options like this. You have 2 options. Which one's actually bigger? How are we going to figure that out? What are we going to need to calculate?
$1.
Effective rate. Yeah. But notice they're not saying effective rate anywhere. So you just have to realize that. So let me write that in. So effective rate. In order to compare two investment situations that compound differently, you're going to in order to compare apples with apples, you're going to have to find the effective rate for both. So let's find, right, because then we can compare, the actual effect. Then we can see which one's really higher. So let's do the first one. Can you do that? Take 12%, compounded quarterly. Go ahead and figure the effective rate. And what do we always plug in for effective rate?
$1.
$1 for 1 year. Because if you can find out what happens to $1, you can find out the effect. So P is $1, time is 1 year. And the listed rate is 0.12. Compounded quarterly. So 4 times a year, right? N is 4. And then hit the buttons on your calculator. I'm getting 1.12550,881. And then so that's what happened to the $1. The $1 became $1.12550881. And so how do we find out what percentage growth that is?
Subtract the 1 and move the decimal place.
Yeah, cut off the 1, move the decimal 2 places to make it a percentage. 12.55%. I don't know how many. Well, I don't think they say it round. 12.55%. That's the actual effect of this account. Now, what's the actual effect of the other account? Good. Does everybody see? It's just exactly what it says. Because it's only compounded N equals 1 time a year, annually, right? You have a birthday annually. Christmas comes annually. That means once a year, right? So that's 12.5%. So nothing to do there. It's just, if it's annual, it already is the effective rate. Nothing magical there. It's not going to grow. It only gets bigger when you compound more than once a year, huh? Everybody good with that? All right, so which one's actually bigger then?
12%.
Yeah, the compounded quarterly actually has a little bigger effect. It actually makes your money grow by 12.55.
500.
Yeah, it's not a huge effect. But yeah, if you're investing, people that invest big dollars, they care about these differences.
Mm-hmm.
Me and Renee, we don't invest big dollars, so we don't care about these
Man,
that much.
I wish that I could invest money at the same rate that a bank charges interest.
Yeah,
I wish
there it
I
is.
could do that.
You should be a bank.
Oh no. Oh no.
It always reminds me of. Okay, so what rate compounded annually to double an investment in 7 years? Okay, so I think we know. So we're going to back to just the normal formulas now. So just the 2 regular formulas. So which one are we going to use? The big one or the PERT one?
We're gonna use the big one.
Yeah, the compounding is annually, so it's not the PERT. So P1 plus the big one, R over N to the NT. And okay, now how do we do it when they talk about doubling an investment?
I'm gonna say we're gonna use 2 as A
Good.
and 1 as P.
That's a great idea. You could just stick in 2 for A and 1 for P. Because that's doubling, huh? $1 becomes 2. Or if you wanted, you could say, well, how about, could we do 2P and P? Sure. Either way, the P's are going to drop out in a second anyway. It's going to be 2 and 1. If you want to just jump to that, great. Is that making sense? Either way is totally fine. The P's are going to drop out anyway. It's going to be 2 and 1. So for an amount to double means twice the principal, huh? You want the amount to become twice whatever the principal originally was. Do you guys want me to close? Is that just 2P thing? right? If you double your money, then the amount becomes twice the principal. And then the p's just drop out, so you could just put 2 and 1 would be fine. And then this is 1 plus r to the 7th. Everybody good to there? So now we need to solve for r. This is a little harder math situation than we've had. I mean, we've had harder, but it's different. We haven't had this particular math situation where we have like a weird power and we're trying to get rid of find a letter that's inside of it. So what do? Basically, what I'm going to do is I'm going to do a 1/7 power to both sides there. Let me write out exactly what you have on the sideboard at this point. And that is, because there's two situations. We're going to do this now, and then in a problem or two, we're going to do the other one. So and they're very similar. So let's write them down so the difference becomes more clear to you. When there's a number in power that we want to cancel. So when you have a number, that's what we're happening here, right? We have this number up there, this 7, and I got to get rid of it, because I got to get r alone. I got to get rid of the 7, I got to get rid of the 1, so r can be alone, So I can solve for r. So when you have a number in the power that you want to get rid of, what do? You basically put 1 over the number, like you power both sides, 1 over the number, which is the same as rooting, basically. If you want to just root both sides, that's the same thing. That's basically what we're doing. As opposed to what we're going to do in a problem or two, when you have a letter in the power that you want to cancel. What do you do when you have a letter in the power? That's when step 1 is get the base alone, and then L in both sides as we've seen before. Get the base. Get the base alone. L in both sides. Get the base alone, L in both sides. So get the base alone and L in both sides.
So the 1/7 comes out in front.
Yeah, exactly. So, the 1/7 power, both sides, yeah. So come in here. So, all right. So if you missed any of that, it's on the sideboard. So let's do it. So to get rid of that 7, what you do is you 1/7 power both sides, and then these cancel. 1/7 of 7 is just 1, Is that good to there? And so then what do we get on the right side? 1 plus r. The other side is 2 to the 1/7. Bring it over to here. And then how do we finish getting r alone?
-1.
Just jump the 1 or subtract the 1, 2 to the 1/7 minus 1. So there it is, and then just use your calculator, and you'll find the rate. That's what it is. Oops. 2 to the power. You got to put parentheses around that power, right? Because there's more than one thing in the power. Well, you probably have the newer ones that just show the power, then you don't have to. Yeah.
So the reason we're able to take the p's out do we just divide by p? Or we just know that we can take the p's out at the second step?
Oh, yeah. I'm dividing by p. You're right. I'm just not showing it there, Becca. Yeah, I'm just dividing by the p's. Good question. Yeah, I got the p's out by just dividing both sides by p, but it didn't show it. So y'all getting that rate there at the end? You able to get that in your calculator? 2 to 1/7 power minus 1. And then they want you to make it a percentage like always. Move it 2 places. 10.4. I think they want it rounded 2 places. 10.41%. That's the rate that would double your money in 7 years.
Let me know where the substitution is, and I'll go.
We good? Questions I can answer? Does that make sense? So when you have a number in the power zone, 1 over that number, power both sides. But now in a second, we're going to have a letter up there in the power zone. That's when we L in. Is that good? Because I hope that's real clear, because those two differences, right? So when there's a letter in the power sign, that's when you LN both sides. Okay. So let's keep going then. So what rate, compounded quarterly, will yield an effective rate of 9%? So what rate, compounded quarterly, will yield an effective rate of 9%? All right, now, as we dive in, before we just go real quick into the thing, I want to just help you think about the big picture for a second. Are we expecting an answer that's smaller than 9, like 8 something, or bigger than 9, like, smaller or bigger than 9? What kind of answer do you think we're expecting? Smaller. Does that make sense? That's correct. That means you're thinking right about it if you're thinking smaller, right? Because it's got to be, so remember, effective rates are always higher. So we're looking for a smaller number, like 8.5 or whatever, that grows to an effective rate of 9. Everybody see the idea? The word effective is very important in here, right? Effective rate is 9. Remember, that's the higher rate when you compound. Everybody getting that big idea first off, right? So they list a rate. They can say, hey, we're going to pay 8% compounded, every day, and it'll grow to be an effect. What the actual effect, it'll be like 8.9% or something, right? They grow higher. The effective rates are always higher, which is bad news for a loan, good news for an investment. So, right, we good there? The effective rates are always higher. The effect of compounding more than once a year drives it higher. So they're saying, hey, what listed rate will become a higher effective rate of 9%? That's what they're saying. What listed rate will grow to become a higher will have a real effect of 9%. Higher effect of 9%. So we're expecting a lower number like 8 point something to grow and become 9. Now, I hope that makes sense. Secondly, they're telling me the effect. Again, it's so important that you really dial in with the fact that there's two rates going on in this problem, huh? There's the effective rate, what it actually does, and then the listed rate. Just like when you buy a house or a car or whatever, and they say this is a 7% loan, compounded monthly or whatever. They have to, by truth in lending laws, they have to list the actual yield. The effect might be 7.9% or whatever. Anyway, so those are the two different things, right? The listed rate and the effective rate, which is higher. So, okay. What are they giving me? The effective. That which is backwards to the problems we just did a few minutes ago.
That's A, right?
Yeah, they're giving, yeah, that's the A. It's backwards, right? They're giving you the final effect. Earlier, back here, they were saying, right here, they were saying, 12% quarterly, what's the effect? And then we got the higher effect, right? So now, they're giving me the effect. Now, think what effect means. What if I said, hey, guys, I went and I invested in some account, and the effect was 9% growth. So what happened to my $1? If the effect was 9% growth, let's go here. What if I said, hey, I invested in some account, the effect was a 9% growth on my money. What happened to my $1? What did my $1 become? $1.09. Boy, my pencil's not working too good. But are we good there? Maybe I'm just going too quick for it. 1.09. That would be the A. You tracking with me? Right? If something grows by 9%, then $1 becomes $1.09. Do you see why it's $1.09 and not just the 9? Because the amount has to include the original dollar and the 9-cent growth. Both. That's the new amount. So the new amount is going to be $1.09. That's what effective 9% growth means. $1 becomes $1.09. Okay, probably beat that to death. You're like, we got it. Mr. Heron, we got it. All right. So let's go back then. So which formula am I going to use? The big one, right? A equals P 1 plus R over n to the nt. And what am I going to put in for A? Since the effect on my dollar was 9%, I put the principal in as $1, right? My $1 will become what? $1.09. Is everybody seeing that? That's what it means when they tell you the actual effect is 9%. That means your $1 actually grew to become an amount $1.09, the original dollar and the 9% growth. And then 1 plus R, I don't know R, that's the listed rate. That's what we're trying to find. And what's in?
4.
It's what it has been all day, huh? Quarter, it seems like they're all quarterly examples. And the time, what is the time?
1 year.
Yeah, it's always 1 year when you're talking about the effect. You mean the effect for 1 year, the annual effect.
So are we gonna 1/4 both sides?
Exactly.
Oh, okay.
Yeah, so we need to solve that. So here we are again with a number in the power zone. So this is 1.09 is 1 plus R over 4 to the 4th. And so how do you get rid of that? So you got to solve for R. R's saying I want to be alone over here. Get rid of this 4 power, then get rid of this 1, and then get rid of this 4 that I'm dividing. One at a time, 3 steps to get R alone. Start with the power. How do you get rid of that 4? 1/4 power, 1 over 4 power, huh? That's what I'm saying over there on the sideboard, what I wrote up a minute ago, that right here, when you have a number in power, you 1 over that number, power both sides. So I'm going to go parentheses 1/4, parenthesis 1/4, and then those cancel, don't they? That's how you get rid of a number in the power zone. You 1 over the number, power both sides.
Now, do you have to multiply each term by 4? Each individual term?
So I'm going to next subtract the 1. We good to there? But you could do it your way too, Renee. That would work also. So I'm just going to subtract the 1. Everybody good to this point? So all the powers vanished on the right side, didn't they? The 4 and the 1/4 canceled. That's why we did it. And now we just subtract the 1. So I'll get 1.09 to the 1/4 minus 1 equals R over 4. We good there? Let's go to a fresh screen. So 1.09 to the 1/4 minus 1 is R 4. Everybody good to there? With the steps, we're trying to get R alone, so a little trickery to get R alone here. So first we got rid of the power by 1/4ing the power. And then we subtracted the 1 to the other side, or just jump it to the other side, becomes a minus 1, right? And now, finally, how do we get rid of the 4? We want to get R alone, we've got to get rid of that 4 that's dividing him. And so we just multiply both sides by 4, and it cancels, huh? So R is alone. Hit the buttons on your calculator.
Now, with this answer, is it giving us the rate straight up, or are we going to have to move?
No, this is, yeah, straight out the listed rate. So we move the decimal in 2 places. 8.711. That's the listed rate that would become an actual effect of 9%. Remember the effect was 9%? We expected getting something smaller, and we did.
Did you get 3 in front of yourself?
You good there? Questions I can answer? Is that okay with the calculator and everything?
Maybe you should try putting that in parentheses.
What did I do wrong?
Yeah. All right, so now we're going to say we want to put $20,000 into an investment, and we want to see it grow to $70,000. The investment's 9% compounded continuously. And the question is, how many years will that take? 9%, I think you can typically get that in stock market and stuff. I think it's average. I don't know. I'm not a big investment guy, but I think it is. So anyway, so which formula are we going to use? So this isn't unreasonable. I'm just saying this isn't an unreasonable number. It's reasonable. Yeah, we're going to use the PERT on this one, huh? Because it is continuous compounding. Continuous. Going to use the PERT. 1 Okay, so go ahead and plug in. Let me give you, rather than me just do it real quick. Where does the 20,000 go? Yeah, that's the original P, right? And the 70,000 is the amount later. We good with that? We're going to have that and in a few minutes here when we start the next section, 5.8, the biology and chemistry examples. Well, the same thing, but it'll be like the insects start off with this population, grow to become that population. You know, so it's good. You're getting in your mind. The P is always like for money, it's the principal, the first money put in, the A is the amount later, huh? So, okay. So, yeah, we put in 20,000. That's always the starting money, starting insects, starting whatever. It grows to become 70,000 later. The A is always the amount later. The rate is 0.09. And the time, that's what we're looking for. Okay, now, I'm trying, everybody good to there? We're trying to solve for T.
LM.
Yeah, so that's what I'm putting on the sideboard. That's what I wrote back here. Somewhere. There. When the letter is in the... Now we have a letter up there in the power zone. Get the base alone, L in both sides, huh? Base alone. That's why I have those two options on the side before. These two options right here. Because these two scenarios come up. If you just have a number in the power, that's when you just 1 over number power both sides. But if you have a letter up there, that's when you got to get the base alone and L in both sides. So let's do it. So let's, first step to get the base alone, how do I do that?
Divide by the initial investment.
Yep, divide by that 20,000. And is that 3.5? Equals E 0.09T. And then, what am I going to do? L in both sides. L in, and the whole power drops down. That's what we do when there's letters up there in the power zone. So we'll get 0.09T, ln E, ln 3.5. Yeah, what is the ln of E?
Doesn't that cancel?
Yeah, that's just gone. That's just 1, huh? That's why it's so convenient to use ln when there's an E. Okay, so now how do we bring it over here?
Divide 0.
Yeah, we're basically there. So ln 3.5 is 0.09T. Last step to get T alone, divide by 0.09. T equals
13.9.
13.9. 13.9 what?
Years.
Years, because that's time, huh?
Would they want you to round that to the whole number?
Whatever they want. Let's see. They want 2 decimal places. So 13.92. I got 919, so rounds to 92.
It's kind of weird. You have like point of a year.
Yeah. Well, yeah, so it's almost another year. So look, stop and look at that for just a second. That's kind of, you see why Einstein called compound interest the seventh wonder of the world? That's just under 14 years. Your money will grow from 20,000 to 70,000. And that rate is not crazy. I think that's average rate. I don't know, I'm not an investment guy, but I know for many years that was the average rate that kind of gains you could get typically in money market accounts, stock market, bonds and stuff. Anyway, so yeah, that's impressive, huh? 20,000 grows to 70,000. I mean, you got to leave it for 14 years. That's why investment people are always saying, invest early and leave it, because compound interest is an amazing thing. You want that working for you. Problem is, my money's always gone because I have 5 kids. There's no money left. So
I've seen your van. I've seen you driving your van.
it's scary.
You still drive the green van, don't you?
The tan one? T was in the power zone. So everybody getting those 2 different game plans. Probably both of them on the exam, both of them in the homework. So back here we had letter. Right here we had, looking back to number 18, we had a number in the power zone. You 1 over number it. Gets rid of it, right? But on this one, we had a letter in the power zone. That's get the base alone, L in both sides. Those are the 2 different strategies. This thing says the average cost of college. So,
Those are UC prices.
average cost of college for a year. This is just one. $34,338 per year. That's crazy. You know, that seems like a lot to me. That must be including private colleges and stuff.
I was thinking it was including like housing.
Well, yeah, well, like my daughter's at more expensive. UC might be 30, including housing and food. That's housing, food, everything. Yeah, so 34. I think they're including, places like USC, which are 80,000 a year. Crazy place. So they bring up the average. Anyway, that's expensive. So that's why I believe in going local to Fresno State, and because it's much cheaper. Anyway, so now they're going to say it's going to go up 9.1% per year. If it goes up 9.1% per year, how much in, I think they said 12, is it 12 years? Yeah, 12 years. How much 12 years from now? That's the question. You've probably seen all the studies. They say that college costs for the last decade, or probably even a little bit more, have been rising faster than inflation, like double or triple inflation. Why is that happening? I have no idea, but it's painful, isn't it? Right? I mean, college is going up, like all the prices, inflation, all the prices are rising. Even fast food now, right? With all the minimum wages going up, everything's getting more expensive, even fast food. But college is like going double or triple inflation, and it has been for a long time, like for more than a decade. So it's getting really, really expensive. So anyway, so basically this is an inflation question. How do you do inflation? So here we're seeing some good economic principles here on how to do that. So what formula are we going to use when they say basically something's going up? This is like inflation. Inflation is usually about 2.5%. Isn't that what it usually is? Typically, if you type into Google something like what's been inflation the last, is it close to 3? So somewhere between 2 and 3 usually is inflation. So this is way more than, this is like more than triple inflation. So which is realistic. That's what it's been for the last decade or so. Anyway, so what formula? Well, it's same two formulas. Now, what's the compounding? That can be a little weird. Like, what's the compounding? It's just once per year. N is just one time per year. How do I know that? Well, that's what it means when they say something is going up a percentage per year. That means every year, 9.1%. Then one more year later, 9.1%. So that's just once per year compounding. That's what you would do with inflation. So if you ever want to take a price and inflate it over a few years, you just do compounding once a year. This formula will do it. It's exactly what you use. So A equals P, 1 plus R over N to the NT, like that. So plug in, so we're trying to find what will the amount be. So this is economic. Do you guys this is the end of our economics application. You guys like economics?
Yes.
I think it's very interesting. Especially macro, like how the whole systems work. I just took one GE class when I was in college of it, It's kind of like psychology. I just took one. I thought they were both very interesting. I wanted to learn more in both of them, but, I had to get on with my other stuff. But I think it's very interesting. You've taken my good friend, Mr. Pankratz, here on campus. Teaches economics. Anyway, good stuff, interesting stuff. All right, so P... So what's the principal? 34,338.
Oh my God.
It comes out big, it's shocking. I can see that Renee has the answer. Yes, the listed rate, 9.1%. Well, so we got to put that as a decimal, right? So that'll be 0.091. Over N is 1 because we're just compounding once a year. That's what inflation is, once per year. And the time is 12 years.
I didn't know I was paying the same amount to be a doctor.
Yeah, that's what I thought too. I thought, is that medical school? Yeah.
Not even going to be a doctor.
Okay, so does that all make sense how we got all those things? So the rate's 0.091, made it a decimal there. The N is always once per year, 12 years. Okay, hit the buttons on your calculator. You're going to get a shocking answer. This is 1 year of college. It's just not funny.
Nobody's ever going to be able to afford that.
Let's see.
That's ridiculous.
So yeah, $97,649.95. Better start saving. There it is.
I got a different answer.
Oh, maybe I hit something wrong.
I
0.091.
got the same thing as you did.
Got what I got?
Yeah.
Okay.
I entered the same thing and I got that.
Let me see real quick. Does that make, and especially, you know, you hear about all the young people that go